Thank you, Senators. On September 24, 2024, the Standing Senate Committee on Fisheries and Oceans was authorized to examine and report on ocean carbon sequestration and its use in Canada. Today, under this mandate, the committee will be hearing from the following individuals: Dr. Anya Waite, CEO and Scientific Director of Ocean Frontier Institute, and Dr. Galen McKinley, Professor of Earth and Environmental Sciences at Columbia University. On behalf of the committee members, I thank both of you for being here and joining us today. I understand that you both have opening remarks, so following those remarks, members of our committee, I'm sure, will have questions for you. So, Dr. Waite, you have the floor. Thank you.
Thank you very much, Senator, and ladies and gentlemen of the committee, good morning, and thank you very much for the opportunity to talk to you today. As CEO and Scientific Director of the Ocean Frontier Institute, our institute builds large ocean research programs with hundreds of researchers. We're focused primarily in Eastern Canada, but we reach across the country and we include major international research centers in the US and Europe. And I've been asked to include a little bit of the scope of our institute's work in my comments today. Ocean Frontier Institute's global consortia tackle three big ocean challenges: fisheries and aquaculture, biodiversity, and climate change. And in the Senate study here, of course, we're talking about that third challenge, climate change and the ocean's role in controlling it. And this is an area where Ocean Frontier Institute has been working since 2016 to build critical conversations between researchers, industry, and policymakers. We drive these conversations not just in Canada, but in the international arena through UN bodies, and we link with everyone from startups to international finance. I was co-chair of the Global Ocean Observing System under IOC UNESCO for 4 years, called GOOSE, and currently I lead GOOSE's Ocean Carbon Exemplar that seeks to build global linkages between nations and the UN in the ocean carbon discussion. We're now turning our attention to how this work can inform and lift Canadian leadership in this area. So you've heard about carbon capture, no doubt. And these are technologies that collect carbon at source before they're emitted, essentially catching carbon from the smokestack. What we're looking for here in our discussion today is what we're talking about is a carbon removal technology. And that is a process that removes the bulk of long-term carbon accumulation from the atmosphere and stores it safely for centuries. On land, this would be in the form of long-lived trees, potentially, or direct air capture facilities known as DAC. So I'll go over some of the things you've heard already, but I don't think necessarily repetition is bad in this case. It's a little technical. So let's talk a little bit about the ocean's two big jobs, absorbing and storing carbon and heat. The ocean has absorbed 90% of the heat humans have produced in the industrial era, and they store 80% of the carbon on Earth. And that equates to 50 times the carbon dioxide in the atmosphere, or 40 trillion tons. So annually, the ocean continues to absorb about 25% of our carbon emissions and plays a critical role in regulating the climate, continues, in fact, to save us from the worst impacts of our carbon dioxide release. Because of its enormous storage capacity, we're studying the ocean as a possible storage depot where additional carbon might be removed from the atmosphere and stored. And we do that through natural processes like chemical absorption and physical mixing of carbon dioxide into the interior of the ocean, and biological growth followed by sinking of biological carbon, that can be plankton or animals, into the deep sea. These processes happen naturally, but they can also be initiated or accelerated by human action. And this is what's known as marine carbon dioxide removal, or MCDR. So let's think about what carbon removal on land can do versus the world's current emissions. And then let's think about an annual emission for the whole world. So how much we are currently as humans releasing of carbon into the atmosphere. So 100 million trees, if you planted them, would take up 34 minutes of our annual global carbon dioxide release. All of the Panama mangroves that have been beautifully set aside for conservation, that's 8,500 hectares, give you 24 seconds relief on carbon dioxide emissions. 18 direct air capture units gives you 8 seconds. Now, we hope that direct air capture will scale up, but that hasn't happened to date. The ocean, in its natural state, gives us already 3 months of uptake. And so a 1% increase in ocean carbon uptake gives you a full day of total net zero sequestration. So how do we get this action right? The ocean can do this work for us, but we want to save the world from extreme impacts of climate change, but we want to do that effectively. We want to do that with ecologically sound work. So marine carbon dioxide removal is now a nascent industry in Canada. Innovators and entrepreneurs, and you've heard from some of them in the earlier sessions, are developing tools and techniques to enable MCDR. They're presenting an outstanding opportunity for Canada to demonstrate science, innovation, climate, and policy leadership, and ultimately more economic development opportunities. These four areas are critical pieces of a conjoined framework for MCDR in Canada, and it's critical that this sector is developed through expert support and regulatory structures that are really grounded in that world-class ocean science, policy, and engagement, and free of any conflicts of interest. The Ocean Frontier Institute works regionally, nationally, and in the intergovernmental policy arena to inform leadership in MCDR, to support public good, and to enable a nimble and environmentally sound MCDR sector. So we need a few things to get this right. We need good scientific leadership to coordinate and lead science, modeling, instrumentation, and so on. Develop that understanding of the ocean baseline, which we know is already changing, but we don't know quite how fast. And we also need to build collaboration with partners, including the international research experts such as Dr. McKinley, who's on the call today. We then need regulatory leadership to inform regulators at all levels and startups on the best available science to evaluate these changing technologies and to reflect current business challenges and opportunities. We need, thirdly, to engage with communities, particularly Indigenous communities, to understand their core concerns and co-create effective strategies to build trust and partnership, for the broadest public good and benefits. Ultimately, we need an economic strategy to help build the necessary financial ecosystem, project financing, and procurement to build a thriving and sustainable MCDR market. So MCDR represents a range of ocean climate interventions that, in combination with emissions reductions, can help save us from the most extreme impacts of climate change. And if they're enabled with the correct science, regulation, public engagement, and economic strategy, this could be the foundation of a whole new research focus and a vibrant new industry while protecting people and communities in Canada. Thank you.